Hello AP Statistics students. In this video, we're going to take a look at two things: percentiles and cumulative relative frequency graphs. I promise it's not as hard as it sounds. So our objective here, we will compute percentiles of an individual in a distribution and read/interpret cumulative relative frequency graphs. All right, so to start with, percentiles. I'm guessing you've heard of percentiles, but many people misinterpret them. You often get them on a score sheet for like your PSATs and your SATs, but it's not a number that tells you how many questions you got right. All right, it's not that kind of percent. Instead, it is the percent of observations or people or data points that are less than or equal to a given value, more like your value. So it is essentially how many people you beat, including yourself, because it's less than or equal to. All right, it's how many people you did better than. And yes, you do better than yourself. So if you got your SAT scores and you were in the 92nd percentile, oops, I said that wrong. I'll talk about that. You were at the 92nd percentile. That means you did better than or the same as 92% of other students. All right, you didn't get a 92%. You did better than or equal to 92%. Or 92% of other people were less than or equal to you. All right, and I already messed this up once. The language, you are at a percentile, not in a percentile. I struggle with that one. I'm guessing everyone's going to struggle with that one, but technically you are at a percentile. All right, let's do an example. Mr. Tabor's first test. Refer to the dot plot of 25 scores on Mr. Tabor's first statistics test. Find the percentile for Jacob. Poor Jacob, who'd scored 18 on the test. So what is his percentile? So 18, Jacob, poor Jacob is right there. He got 18 on this test. What is his percentile? So remember, the percentile is how many people did less than or equal to you. So that would be both of these dots. This one is Jacob. This one is the poor person that did even worse than Jacob. How many people did less than or equal to Jacob as a percent? So there were 2 students who did worse. Out of the total of 25, gives you a proportion of 0.08, which is the 8th percentile. So Jacob is, there's the word at, the 8th percentile on this test. All right, because 2 out of the 25 are less than or equal to Jacob's 18. Now we're going to do that same thing, but backwards. 48%, part B. Maria's test score is at the 48th percentile of the distribution. Interpret this value in context. What score did Maria earn? All right, so if she's at the 48th percentile, that means that 48% of the students in the class earned a test score less than or equal to Maria's. All right, she beat or was equal to 48% of the other students. All right, now how do you turn that into a actual score? Well, you got to figure out how many students Maria actually beat, not as a percentile, but as an actual number. So 48% of the 25 means that she beat 12 other students, okay? So you have to count to the 12th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means Maria is right there. All right, because she has beaten or is equal to these 12 other students. What is that score? 35, 36, 37. she got a 37 on the test. So we got kind of an algebra 1 thing going here. In letter A, we kind of gave you X, you had to find Y. And then in letter B, we gave you Y and you had to find X. Kind of a forward and backward thing going. All right, let's take a look at an example. How many pairs of shoes does a typical teenage boy own? To find out, 2 AP Statistics students surveyed a random sample of 20 male students from their large high school and recorded the number of pairs of shoes each boy owned. Here are the data, along with a nice dot plot. One of the students in class has 10 pairs of shoes. Find and interpret this student's percentile. All right, so we have to find the 10 pairs of shoes and how many were less than or equal to that 10 pair of shoes. So 10 pairs of shoes is right here. How many are less than or equal to? So we have to take all of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 students out of the total of 20 students puts us at, divided by 20, 0.7, which would be the 70th percentile. Okay, so to put that into a sentence, this student is at the 70th percentile for shoe ownership at this, maybe not at the high school, but in this sample. This means this means that 70% of students had less than or equal to 10 shoes. Okay. All right. Now we're going to go the other way. Jaren is at the 45th percentile for shoe ownership in this class. How many shoes does Jaren have? All right, so we're doing the same thing but backwards. Jaren there are 45% of students are less than or equal to his number of shoes. How many kids is that? So we take his percentile, which is 0.45, times the number of kids in this sample, which was 20. How many students were less than or equal to Jaren's? So Jaren was 0.45 times 20. Oops, I did 30 there for a second. 29. All right, so there are 9 students less than or equal to Jaren. So where does that put us? So let's count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here is Jaren. So what shoes, how many shoes does that give us? 5, 6, 7. All right, Jaren has 7 shoes. I guess pairs, sorry. 7 shoes would be kind of weird. Mix and match. All right. Sammy calls BS on Jared's claim of being at the 45th percentile. Sammy has 6 pairs of shoes, only 1 less than Jaren. But he is only at the 25th percentile? What gives? All right. Why? He only has 1 less pair, 6 pairs. All right, take a look at the dot plot. Maybe pause the video, see if you can figure out why 6 pairs of shoes is the 25th percentile, but 7 pairs of shoes is the 45th percentile. All right, I assume you pause it there. It's because so many students had 7 pairs of shoes. If you go down even 1 pair of shoes, now you are only people less than or equal to you are 1, 2, 3, 4. There's only 5 students that are less than or equal to 6 pairs of shoes. But if you go one pair higher, there are now 9 students, and that big jump, all those kids at 7 pair of shoes, bumps the percentile up so much. It's a problem with small sample sizes as well, because we only asked 20 people. All right, now for those graphs that just sound horrific. Trust me, they're not that bad. A cumulative relative frequency graph. This is basically a graph of percentiles, okay? And let's break down these words here. You know what the word cumulative means. It's the kind of test that we all fear, but we all know is coming. It means everything up until a certain point, all right? The next, relative frequency. We know what relative frequency means. That simply means a percent, okay? So it is cumulative, adding up or comprising of all the percents up to a certain point, which hopefully makes you think of percentile. All right, let's break this down a little bit more. Here is a big table that shows you how cumulative relative frequencies are calculated. No, I don't think you ever have to actually make one of these, but you should understand where the numbers come from. So, at what age do presidents take office? Let's look at the data. So here are the age distributions for when presidents took office. So to read this, 12 presidents took office between the ages of 55 and 60. 3 presidents took office at the age of 65 to 70 when they first started. Okay? Those are our frequencies. That's like our raw data. Well, we can turn that into relative frequencies, and again, relative frequency just means percent. So you turn these numbers into a percent. To do that, you simply, as you can see the math here, divide by the total. That gives us our relative frequencies. We're pretty familiar with that. What we haven't done is the cumulative frequencies, where we add up all the ones before. So that would be a question like, how many presidents took office before the age of 60? All right, I'm looking at all the ones before 60. Well, to do that, I would add up all of these, all right, which gives you 34. Well, now we just got to add the word relative into that. We take this number and we divide it by the total to turn it into a percent. So 34 presidents took office before the age of 60. Or I could say 75.6% of presidents took office before the age of 60. So that is a cumulative relative frequency, also known as a percentile. And so now all we got to do is turn that into a graph, which I don't have here. Insert picture from file. Where is it? I just took it. Right here. There is the cumulative relative frequency. A little faster than me drawing it by hand. So where do these numbers come from? On the left are our percents, all right, 0 to 100%. On the bottom are variable. So presidents, none of them were lower than 40, so we started the graph at 40, up to 75 because none of them started over the age of 75. So that is the age in years when they were started being president. All right, then we take a look. How many were president before the age of 40? None. That's why there is a dot at 0. How many were by, let's say, by that 60? How many were in office by the age of 60? 75.6. So at 60, that dot is at 75.6. We have a dot for each one of our rows here, which then gives us our cumulative relative frequency graph. You don't necessarily have to draw those very often, but you do need to interpret them. So we're going to take this graph and answer some questions about it. All right, so use the graph in figure 2.2 to help you answer each question. Was Barack Obama, who was first inaugurated at age 47 years, 169 days, we keep track of this for some reason, man, about 47.4 years, unusually young? So what we do is we go to our cumulative frequency graph and we find 47.463 right here. And then, oops, get a marker here. We find where that intersects the graph, and then we come over to the side here and find the y value, which is about 12, which is a percentile, a cumulative relative frequency. So that means Barack Obama, his age for inauguration, put him in at the 12th percentile. So about 12% of the first 45 US presidents took office by the time they were 47 years old. Is that super rare or unusually young? He was young, but not super unusual because 12% were younger when he took office. Okay? All right, now we're going to do the algebra thing. We basically gave you the x and asked you to find the y. Now we ask you, or we give you the y and we ask for the x. Estimate and interpret the 65th percentile. Well, a percentile is a cumulative relative frequency. So that's our y value. So we come up here and find 65 on the y-axis. This is the 65th percentile. What age does that correspond to? It intersects right there, about 58. So the 65th percentile is about 58 years old. Another way of saying that, about 65% of the first 45 US presidents took office by the time they turned 58. All right, you might want to pause it, write those sentences down. Those are the kinds of things you want to be able to say and put into words. All right, now let's do our own. So here is a cumulative relative frequency graph for the length of phone calls. Do you even call people anymore? Be honest, you have to like text them before you call them, right? It's like, hey man, can I call you? Sure, go for it. All right, ring. I feel like that's how it goes these days. About what percent of calls lasted less than or equal to 30 minutes? All right, so we go to 30 minutes. And then we follow that up. And then we follow that over as straight as you can. So that's probably less than 70. Let's call that 65 maybe. So 65% of calls lasted less than or equal to 30 minutes. I'll write that out. Okay. 65% of calls lasted less than or equal to 30 minutes. All right. Another way of saying that, a 30-minute call is at the 65th percentile for call length. All right, more than 30 minutes, that would just be what's called the complement, right? If 65% are less, 35% will be more. So 35% would be more. All right, now estimate Q1, Q3, and the IQR. All right, that sounds complicated, but remember Q1, the median, Q3, those break the data up into 25% chunks. So Q1 is at the 25th percentile. So I'm going to come over here. See, this is about 30. So this is about 25. that is Q1. Now, where does that put us on our graph? About there. What's between 10 and 15? About 12.5. So that is the 25th percentile. All right, now Q3. Where does that put us? Well, again, we're breaking this up into quarters. Don't forget the median is at the 50th percentile, 50% of the data. Q3 would be at 75 then. So 70 is right about here. 75 would be right about here. And that is Q3. So now we got to draw that across as accurately as possible. Puts us right about there. Something like that. So that would be what, maybe 32-ish? Let's call 32. All right, so that is Q1, Q3. Our IQR is simply subtracting those. 32 minus 12.5, which is equal to 19.5 minutes. All right, so the interquartile range, all right, the range of time between a 25th percentile call and a 75th percentile call is 19.5 minutes. Anywhere between a 12.5-minute phone call and a 32-minute phone call. All right, so that is how we can use a cumulative relative frequency graph to do some analysis. I hope that made some sense.